Every minute, more than 55 short tons of whey protein are produced worldwide. But just a few decades ago, people would simply pour out this liquid, not realizing it held one of the purest sources of protein. Today, it is a multi-billion-dollar industry where ordinary whey from milk undergoes a high-tech journey of filtration, drying, and packaging before ending up in your sports shake. How did this ordinary byproduct of the dairy industry become the foundation of sports nutrition? Let us figure it out. The cycle begins with choosing high-quality raw materials. Do you know what whey is, if we are not talking about vaccines? When milk is used to make cheese or yogurt, it separates into two parts: the solid curd that becomes cheese, and the liquid whey, which was thrown away or used as animal feed several decades ago. However, people discovered that this liquid is full of valuable proteins, so it is now filtered, dried, and transformed into powder. The same whey protein you find on store shelves. When milk curdles, only 10 or 20% of it turns into cheese, while the remaining 80 or 90% is whey. Most large protein producers work directly with farms located near their factories to secure a steady supply of this raw material. In the United States of America and Europe, whey often comes from large dairy farms. In Australia and New Zealand, it is commonly sourced from traditional pasture-based farms, where cows eat natural grass. The quality of the protein depends on the quality of the milk, and that quality is influenced by how cows are raised. This is why some brands emphasize that their whey protein is from grass-fed cows, without antibiotics or hormones, and from certified dairy farms. The type of final product also depends on the milk's fat content. If the milk is used to produce a full-fat cheese, such as cheddar or Gouda, the resulting whey has less fat and is more suitable for making a pure protein powder. If it is a lower-fat cheese or cultured dairy product, the whey may contain more lactose, which affects the flavor and overall quality of the final powder. Many whey protein manufacturers prefer whey from hard cheeses because it typically has a higher concentration of pure protein and fewer byproducts. To make about 2 pounds of cheese, you need approximately 2 1/2 gallons of milk, and the rest of that milk turns into liquid whey, which can be used to obtain protein. Whey protein naturally contains very little fat, since most of the fat stays in the cheese. The whey that will be turned into protein is transported to factories in special sealed containers or tankers. Because whey is a liquid that spoils quickly, it must be delivered at low temperatures to maintain its quality. Once whey is collected from the milk, it is cooled to around 39 degrees Fahrenheit to reduce the risk of bacterial growth. For transport, specialized insulated tankers or trucks with refrigerated compartments are used. These vehicles can maintain a constant temperature to keep the whey fresh during the trip. Transport containers are typically airtight to prevent air from spoiling the whey and to preserve its quality. After delivery, the whey is usually tested to ensure it meets the standards required for further processing into protein. This transport system guarantees that the whey arrives at the factory with its beneficial properties intact and is ready for the next steps of protein powder production. Once the whey reaches the plant, it is carefully transferred from the tankers into large, specialized reservoirs. These are often stainless steel vats or other containers that keep the liquid hygienic. If the whey has not yet been cooled to the ideal temperature, it undergoes additional chilling to prevent bacterial growth and to provide optimal conditions for the next manufacturing stages. At this stage, the whey may pass through filters to remove any foreign particles or unwanted impurities. This step is crucial to avoid quality issues later in the protein production process. Often, the whey is first concentrated by removing some of the water through ultrafiltration or other techniques, which increases the protein content. In certain cases, the whey may be heated to activate specific enzymes or prepare it for subsequent processes, thereby improving the efficiency of protein extraction. Protein, also called a protein molecule, is an organic compound composed of amino acids linked by peptide bonds. It is a major building block of the cells in living organisms and performs numerous vital functions within the body. Proteins play a key role in forming tissues, cells, and organs, as well as in driving various processes essential for an organism's life activities. They are the main components of cells and tissues. Proteins create structures like muscles, skin, hair, nails, organs, and other tissues. Many enzymes are proteins that speed up chemical reactions in the body, including food breakdown, energy production, and other important biochemical functions. Proteins are involved in the transport of molecules and ions in the body, such as hemoglobin, which carries oxygen in the blood. They also regulate various biological processes, including growth and development, and support the body's immune defenses in the form of antibodies. Although supplying energy is not the primary role of protein, the body can use it as an energy source when necessary, especially if carbohydrates and fats are in short supply. Proteins consist of 20 main amino acids, 9 of which are essential, meaning the human body cannot produce them, and they must come from food. Animal products like meat, fish, milk, and eggs contain all the essential amino acids, making them complete protein sources. Membrane filtration is a critical step in processing whey for protein powder production. It allows an efficient separation of the beneficial protein from less useful components, such as lactose, fats, and minerals. This procedure employs special filtration membranes with microscopic pores, functioning like extremely fine sieves that only allow molecules of certain sizes, including proteins, to pass through. 3 main types of membranes are typically used for membrane filtration: ultrafiltration, nanofiltration, and reverse osmosis. In the first stage, membranes with larger pores let water, lactose, and minerals pass through, while holding back larger protein molecules. Nanofiltration membranes have smaller pores, allowing only smaller molecules such as minerals to pass, while retaining bigger protein molecules. The final step, often referred to simply as osmosis in a reverse osmosis system, helps remove water and small molecules like lactose, resulting in a concentrated protein. Once the whey enters the membrane system, it is pushed through the membranes under pressure. The portion of the liquid that contains dissolved substances such as water, lactose, and minerals passes through the membrane, while larger protein molecules remain on the membrane's surface. This approach yields a more concentrated protein. After membrane filtration, the whey is divided into 2 streams. One contains the larger protein molecules, the concentrated protein, which will be further refined into protein powder. The other includes lactose, minerals, and water, and may be discarded or used for other food or industrial purposes. This process can be repeated multiple times to further boost protein concentration, resulting in protein concentrate or protein isolate, which differ in their levels of purity. Following membrane filtration, once the whey has reached a high protein concentration, the next step is drying. This is crucial because it transforms the liquid concentrate into a powdered form that is easy to store, transport, and use. One of the most widespread methods involves exposing the whey concentrate to a stream of heated air, which evaporates the moisture and leaves behind powder. This approach is sometimes referred to as hot air drying, or a form of air-based microfiltration, and it is commonly used to produce powders with a high protein content. In the case of rotary dryers, the whey concentrate is dispensed onto rapidly rotating drums heated by hot air, causing the moisture to evaporate. Another frequently used technique is spray drying, where the whey is sprayed into fine droplets in a chamber that circulates hot air. The droplets quickly lose moisture, forming small particles of powder that readily dissolve in water. During drying, it is crucial to control the temperature, because very high temperatures could damage protein molecules or compromise the final product's quality. Typically, the temperature does not exceed 175 degrees Fahrenheit in order to retain all of the protein's beneficial properties. After this step, the whey becomes a powder with a moisture content of less than 5%. The powder is then stored in sealed packages to prevent it from absorbing moisture from the air. That is all there is to it. The only remaining task is to package the finished protein. Modern factories use high-speed packaging lines. For example, a single automated line can fill up to 40 packages per minute. Over one day, it can pack around 50,000 packages of protein powder, which usually totals 2 or 3 short tons of finished product. The packaging process is completely automated. Powder travels directly from a container or hopper into packaging machines that automatically fill each package with gram-level accuracy, ensuring precise dosing. Packaging machines operate not only at high speed, but also with great precision. They can include sealed closure systems to prevent air and moisture from entering, which helps the product remain fresh. An automated system inspects every package to detect any defects, such as incomplete sealing, and discards flawed packages. Once the protein powder is packed, the packages may be automatically marked, labeled, and moved onto a conveyor for further boxing or palletizing for shipment. These machines are capable of packing up to 1,000 packages per hour into a single box, guaranteeing rapid and efficient delivery of the final product to consumers around the world. This is California, USA, where around 1.7 million cows on thousands of dairy farms produce more than 13 million gallons of milk every day. So, how does this massive amount turn into the sweet treat that once saved soldiers' lives and changed history? I visited one of the largest factories in the world to dive into the fascinating process of making condensed milk and to share the story with you. In 1856, American inventor Gale Borden first came up with this product. His creation solved the dilemma of preserving milk in the days before refrigerators, making it possible to store milk in cans for at least a year. During the American Civil War, it played a crucial role in supplying soldiers with milk in combat zones where dairy cows were not available. Thanks to its long shelf life and valuable nutritional properties, it became the preferred choice for feeding soldiers. The process of making condensed milk begins on dairy farms. To meet the high demand for this delicious product, factories like Nestlé's in California operate around the clock, 24 hours a day, 7 days a week. This factory processes more than 420,000 gallons of milk daily. Massive tank trucks arrive non-stop, transporting between 130,000 and 185,000 gallons of milk each day from nearby farms. Most of the incoming milk was collected just 6 hours earlier, so it's incredibly fresh. However, before the milk is accepted, it undergoes lab testing. The fat and salt content must meet factory standards, and the milk must be free of antibiotics to avoid allergic reactions in some people. But where do the farmers get such milk? Most of the milk in the US comes from roughly 60,000 dairy farms, where over 9 million cows are raised specifically for milk production. Over the past century, the milking machine has become an essential tool. The part of the machine that attaches to the cow's teat is called a cup, and it works similarly to a hand, applying pressure to the udder to extract milk. A farmer can manually milk about 6 cows per hour, but with a specialized device, that number can jump to 100 cows per hour. The ingenuity of this innovative device has optimized milk production, but the way a farmer cares for their cows also impacts the quality of the milk. The more care given to the animals, the longer their lifespan and the more milk they produce. On this massive dairy farm, 8,000 cows graze. It's one of many farms that use technology to improve cow living conditions and boost productivity. In cow carousels, known as milking parlors, up to 80 cows can be milked at once, twice a day. Dairy cows are creatures of habit, and they enjoy sticking to a routine, which makes the milking process smoother. These advanced milking parlors outperform traditional machines, increasing the milk flow rate by 30%. Before attaching the milking cups, workers disinfect the cow's udders with an iodine solution. This process mimics the sucking motion of a calf to ensure organic milk production. The entire procedure takes about 7 minutes, and after milking, the cups automatically detach. These animals spend around 8 hours a day eating. Consuming 100 pounds of feed and 80 gallons of water, a cow can produce up to 10 gallons of milk a day, 7 days a week. Thanks to technological advancements and more nutrient-rich feeds, today's cows are 3 times more productive than they were 50 years ago. A dairy cow starts producing milk at around 2 years old, once she gives birth to her first calf. Typically, the calf is separated from its mother within an hour of birth to prevent harmful bacteria from reaching the mother's udder. From then on, the calf is bottle-fed with its mother's milk, while the cow begins her career as a milk producer. For 305 consecutive days, the cow is milked twice a day, after which she gets a well-deserved 60-day break to give birth to another calf. Once the cow delivers, the milking process begins all over again. The liquid produced by cows is a nutrient-rich substance that consists of 87% water. This process begins when food is digested in the cow's stomach and transformed into nutrients, which are absorbed into the bloodstream. These nutrients travel to the mammary glands, where they are converted into the valuable liquid we know as milk. Milk is collected from the udder at a temperature of 90 degrees Fahrenheit and transported via pumps into storage tanks, which are then cooled. In these tanks, the milk is stored at a safe temperature of 36 to 37 degrees Fahrenheit. However, at this stage, the milk is still in its natural state and may contain harmful microorganisms. That's why it is loaded into a 5,300-gallon tanker truck and taken to a dairy processing plant. After the milk has passed all stages of quality control, it is sent to a centrifuge separator to speed up the separation process. In the top section, cone-shaped discs spin at an impressive speed of 7,000 revolutions per minute, processing over 5,800 gallons per hour. Under the force of centrifugal action, the heavier skim milk moves outward, while the lighter cream moves toward the center. As a result, we get cream with a fat content of around 20%, and skim milk with a fat content of less than 1%. The skim milk serves as the starting point for making condensed milk. Next, the milk undergoes the pasteurization process to destroy any bacteria present. To begin this procedure, the milk is first cooled to a temperature of around 37 degrees Fahrenheit, then passed through a heat exchanger that raises its temperature to 162 degrees Fahrenheit. After heating, the milk is transferred to a chamber where it is held for 15.5 seconds, achieving the required level of pasteurization. The milk is then cooled back down to 37 degrees Fahrenheit. In less than 40 seconds, complete pasteurization reduces the bacteria count in the product by 99%. Before the introduction of pasteurization technology, most consumed milk was in its natural state, leading to quick spoilage and exposing people to the risk of infection from potentially dangerous microorganisms. In 1862, the famous French scientist Louis Pasteur proposed an innovative solution originally aimed at preventing wine from spoiling, which was later applied to milk. After milk is pasteurized, a large amount of sugar is added to it. The sugar not only gives the milk a sweet taste, but also acts as a preservative, helping to extend its shelf life. The mixture of milk and sugar is reheated so that the sugar fully dissolves and becomes uniform. The heat not only helps dissolve the sugar, but also prevents the formation of crystals that could affect the smooth texture of condensed milk. After this, the milk enters an evaporator, an enormous device designed to remove water from the milk. At this stage, the milk becomes thicker as the water content is reduced by about 60%. Using heat and pressure, the evaporator manages to evaporate the water from the milk without altering its properties, allowing the concentration of solids like proteins, sugars, and fats. This process gives condensed milk its thick texture and delightful sweet flavor. The evaporator consists of a series of vertical structures called calandrias. Inside each calandria is a set of stainless steel tubes through which the milk circulates. A steam chamber surrounds these tubes. The milk enters each calandria from the top and flows down through tiny channels. As it moves downward, the steam enveloping the tubes heats the milk, causing the water within it to evaporate. Once the milk reaches the desired thickness, it is removed from the evaporator. Next, the milk undergoes an additional process called homogenization, where the fat is broken down into small uniform particles to improve its consistency and stability. Before the condensed milk is packaged, the containers must be sterilized to eliminate any microorganisms that could affect the product's quality. Once the condensed milk is processed and has reached the perfect consistency, it is transferred to a packaging machine. These machines precisely measure the required amount of product into each container, ensuring consistency and reducing waste. After filling, the containers are sealed tightly to prevent any contaminants from entering. To ensure the product's safety, the filled and sealed containers undergo an additional sterilization process. The cans are placed in autoclaves, where they are exposed to steam under high pressure to destroy any remaining microorganisms. This procedure ensures that the condensed milk inside the container is completely safe to consume and has a long shelf life. In addition to meeting domestic demand, condensed milk is widely exported around the world. Thanks to its long shelf life and high nutritional value, it is a popular product in countries with limited access to fresh milk. Condensed milk-producing countries like the United States and several European nations actively supply this product to markets in Asia, Africa, and Latin America. The export of condensed milk helps strengthen international trade relationships and ensures that people in various regions have access to quality dairy nutrition. Do you think mayonnaise is just a simple mix of oil and eggs? What if I told you it can polish furniture and elevate your culinary creations to new heights? Today, I'll reveal the secrets behind making America's favorite mayonnaise at the Hellmann's factory and share tips that will blow your mind. Don't miss out. At this factory, thousands of pounds of mayonnaise are produced every day. But the journey to creating this popular sauce starts long before the ingredients even reach the facility. The quality of the final product is directly tied to the raw materials, which is why suppliers are carefully selected. The key components of mayonnaise are vegetable oil, egg yolks, vinegar or lemon juice, and seasonings like salt and mustard. Each of these ingredients plays a crucial role in achieving the perfect taste and texture. The first step in production is sourcing and preparing the ingredients. I watched as vegetable oil was pumped from massive storage tanks into the production area using powerful pumps. Before it's used, the oil goes through additional filtration to remove any potential impurities that may have gotten in during storage. At the same time, pasteurized egg yolks are taken out of the refrigeration units and gradually brought to room temperature. This step ensures they mix more easily with the other ingredients. Vinegar or lemon juice is carefully measured and mixed with water in the correct proportions to achieve the desired level of acidity. This mixture is then combined with salt, mustard powder, and other spices in a special tank for pre-mixing. Everything is thoroughly blended to ensure the dry ingredients are evenly distributed and completely dissolved. When all the components are ready, it's time for the magic to happen: emulsification. Emulsification is the process of combining two liquids that normally don't mix, like oil and water. This is where egg yolk proteins come in as natural emulsifiers. I was amazed by the enormous industrial blenders, known as homogenizers, used for this process. These machines are equipped with powerful mixers and temperature control systems. The process starts with loading the egg yolks into the blender, where the mixers begin spinning at an incredible speed. Then, the vinegar and spice mixture is gradually added. Once the yolks and vinegar are fully combined, the most crucial step begins: slowly adding the oil. The oil is added very slowly, in a thin stream or sprayed, while the mixers continue operating at high speed. This allows the egg yolk proteins to effectively coat the tiny droplets of oil, creating a stable emulsion. This is how the creamy smoothness we all know and love in mayonnaise is achieved. Temperature control during this process is crucial. The temperature is maintained between 68 and 77 degrees Fahrenheit using special cooling systems built into the homogenizers. Once the emulsion is ready, the mayonnaise undergoes an additional mixing stage to ensure uniformity. The mixture is pushed through tiny openings under high pressure, further reducing the size of the oil particles and enhancing the product's consistency. Next, the mayonnaise moves to real-time quality control. Automated systems take samples from the product stream and run quick tests to check for consistency, acidity levels, and appearance. This ensures that the mayonnaise meets all required standards before moving on to the next stage. After passing quality control, the mayonnaise is pumped into temporary stainless steel tanks. At this stage, additional ingredients can be added to create different variations of mayonnaise, like herbs, spices, or other flavorings. Before packaging, the mayonnaise goes through a process to remove any trapped air. Air pockets can not only affect the appearance of the product, but also speed up spoilage due to oxidation. To prevent this, the mayonnaise is placed in special vacuum chambers where all the air is gently removed from the product. Now we move on to the packaging stage, which is equally impressive in terms of technology. The factory is equipped with state-of-the-art packaging machines capable of handling various types of containers, ranging from small glass jars to plastic bottles and large containers for food service establishments. Before filling, each container undergoes thorough cleaning and sterilization. Glass jars are rinsed with hot water and dried with purified air, while plastic containers, which arrive pre-sterilized, are inspected and blown with filtered air to remove any dust particles. The mayonnaise is carefully pumped from the temporary tanks into the packaging machines. The filling process is highly precise to ensure each container receives the exact same amount of product. To prevent air bubbles from forming, the nozzle is slightly submerged in the mayonnaise and rises as the container fills. Once filled, the containers are sealed airtight. For jars and plastic containers, this involves securing lids with precise torque control to guarantee a perfect seal without damaging the container. For soft packaging, heat or ultrasonic sealing is used to ensure a secure closure. The containers are then moved to the labeling stage. Automated machines carefully apply the labels, ensuring precise alignment and no defects. Afterward, each container undergoes a final visual quality check, using high-speed cameras and machine vision systems. This ensures that the product fully meets standards before being sent to the warehouse for further shipping. During my visit to the factory, I also learned a lot of interesting things about the history of mayonnaise. It turns out that its origins date back to the 18th century. According to one popular story, in 1756, during the 7 Years' War, after defeating the British in Port Mahon on the island of Minorca, the chef of the Duke of Richelieu created a sauce made from eggs and oil to celebrate the victory. The sauce was named Mayonnaise, after the city of Mahon. Other sources claim that the sauce already existed in French cuisine and derived from the Old French word moyeu, meaning egg yolk. Either way, mayonnaise quickly gained popularity in France and then throughout Europe. In the early 20th century, with the rise of industrialization, mayonnaise began to be produced on a large scale, making it accessible to the masses and helping to spread it around the world. Now, I'd like to share a few fascinating facts about mayonnaise that really surprised me. Did you know that in Japan, mayonnaise is considered a true delicacy? The Japanese use it not only in salads but also in unexpected dishes like pizza, sushi, and even ice cream. Japanese mayonnaise, such as the popular brand Kewpie, has a richer flavor thanks to the use of rice vinegar and extra egg yolks. Mayonnaise isn't just for food. It can be a helpful household item too. It's used to remove sticker or label residue, polish wooden furniture, and even as a moisturizing hair mask. Thanks to its oil and egg white content, mayonnaise nourishes and hydrates hair. In some countries, mayonnaise is preferred over ketchup as a dipping sauce for French fries. For instance, in Belgium and the Netherlands, fries are traditionally served with mayonnaise, and this is considered a classic pairing. Mayonnaise can also improve your baking. Adding it to cake or cupcake batter makes the final product more moist and tender. This is because mayonnaise contains oil and eggs, which enhance the texture of the dough. The largest Olivier salad ever made used a massive amount of mayonnaise. In 2012, a team of chefs in Moscow set a world record by preparing a salad weighing over 4,000 pounds. They used more than a ton of mayonnaise to achieve this. After visiting the Hellmann's factory, I gained a new appreciation for this everyday sauce. From its meticulous production process to its rich history and surprising uses, mayonnaise is far more interesting than it might seem at first glance. So, the next time you spread it on your sandwich, take a moment to think about the craftsmanship behind each jar. Each year, more than 93 million short tons of delicious oranges are harvested worldwide. Over 60% of that amount is used to produce bottled orange juice. But how is this process carried out in industrial plants? To find out, let's visit a factory in the United States that specializes in producing more than 530,000 gallons of orange juice per day. An orange plantation consists of evergreen trees with vertical trunks and compact rounded canopies. Their sturdy trunks are made of strong wood and covered by a thin bark, which can range in color from green to gray-brown, depending on the layout of the plantation. These trees can grow to heights between 20 and 33 feet. To successfully grow oranges, ideal conditions are required. The perfect elevation for the trees is between 1,600 and 330 feet above sea level, and the optimal temperature is 75 degrees Fahrenheit. It's essential that the soil is slightly alkaline, with good drainage capacity. Sunlight is also crucial, especially during the flowering and fruiting periods. Oranges can be propagated in two ways: sexually through seeds or asexually through grafting. The fruit-bearing timeline depends on the propagation method. If grown from seeds, it can take up to 7 years for the trees to start producing oranges. In contrast, using grafting can reduce this time to about 3 years. Once the tree has flowered, the fruit typically matures over a period of 6 to 14 months. For the best quality and flavor, it is recommended to harvest oranges 2 to 3 months before they fully ripen. Oranges undergo multiple checks to determine their ripeness. The ratio of sugar to water is tested, and when the sugar content reaches at least 10%, they are ready for harvest. Citrus fruits are picked at their peak sweetness and juiciness because they do not continue to ripen after being harvested. For the production of freshly squeezed juice, two main varieties of oranges are typically used: Valencia and Himalayan. These oranges are hand-picked while they are still slightly underripe. Harvesters carefully inspect each orange, discarding any that have cuts or holes to prevent possible damage to the inside. However, on large plantations where many oranges ripen simultaneously, the harvest must be completed quickly. To speed up the process, a device known as a tree shaker is used. This machine grips the tree branches and shakes them vigorously to release the oranges. Capable of harvesting up to 4,400 pounds of oranges per minute, it greatly accelerates the harvest in large citrus groves. Although mechanical harvesters, which can cost around $500,000, are able to collect between 88,000 and 110,000 short tons of oranges per year, many farms still rely on manual labor, requiring hundreds of workers to get the job done. Workers carefully place the juicy oranges into large canvas bags and carry them to containers. This manual approach allows for more careful selection and reduces the impact on the fruit. The juicy oranges are sent to the juice production plant and first pass through a cleaning station, which works much like a car wash at a gas station. An environmentally friendly soap solution is applied to the fruit, and rotating nylon brushes scrub them as they move along a long conveyor belt. Afterward, the soap is rinsed off with cold water, and the oranges are dried using blasts of air from fans. Once they exit the drying machine, the fruit is carefully inspected by a specialist to ensure that no bad oranges were missed. At the sorting stage, some modern production lines are equipped with more advanced scanners that provide additional assistance in identifying any issues. In the final step, the oranges pass through a series of gentle brushes that remove any remaining dust and dirt. It's time to move on to the juicing process, the most crucial step in producing delicious orange juice. After thorough cleaning, the oranges are fed into a machine known as an extractor. This extractor was specifically designed to maximize both the efficiency and quality of the juice. It consists of a pair of round metal ridges that forcefully pierce the orange peel, remove it, and extract the juice. During this process, not only is the essential liquid extracted, but also the seeds and the bitter white layer, called the albedo, which separates the soft pulp from the tough outer skin. The goal is to produce juice that is as pure and flavorful as possible, free of any components that might negatively affect its taste or texture. After the juice is extracted, the nectar is collected in a reservoir. Here it passes through a filtration system that allows the pulp level to be adjusted based on customer preference. Fine mesh filters produce a smooth, clear juice, while more open filters let through small pieces of pulp, resulting in a thicker, more fibrous juice. The orange juice then undergoes pasteurization to ensure safety. followed by rapid cooling before being bottled or stored in massive 10,500-gallon containers at 39 degrees Fahrenheit to preserve its properties. It takes approximately 13 to 15 oranges to produce 1 quart of juice. This process ensures that every tiny drop of nectar is packed with exquisite, bold flavor, rich in the fruit's valuable nutrients. Before packaging, a thorough quality inspection is conducted to ensure the final product meets the highest standards. Various aspects of the juice, such as sweetness, acidity, pulp content, citrus essence, texture, and most importantly, taste, are checked. These checks guarantee that every batch of orange juice maintains a consistent and refined flavor. After the juice passes quality control, it moves to the bottling line. Cardboard cartons and plastic containers travel along a complex automated production line, where they are filled and sealed tightly to preserve freshness. This procedure is carefully designed to minimize exposure to oxygen and prevent oxidation, ensuring the juice retains its delicious flavor and valuable nutrients. Once bottled, the freshly squeezed orange juice is quickly cooled to prevent any potential spoilage, and then transported in refrigerated trucks to supermarkets across the country. Rapid cooling is essential to maintaining the product's freshness until it reaches consumers. The refrigerated trucks keep the juice at the ideal temperature throughout the entire journey, preventing any changes in taste or quality. From the moment oranges are harvested to when the juice appears on supermarket shelves, every step of the process is carefully planned to ensure that customers can enjoy a product of the highest quality. Thanks to innovative processing methods and strict quality standards, the delicious flavor and nutritional benefits of orange juice are guaranteed to stay fresh and natural. The numerous health benefits of orange juice are truly endless. Packed with vitamins A and C, it boosts the body's immune defenses, helping to prevent illness. It also aids in preventing anemia, as vitamin C enhances the absorption of iron, which is essential for producing hemoglobin and transporting oxygen through the blood. In addition, orange juice helps slow down premature aging due to its antioxidants, such as beta-carotene, lutein, and zeaxanthin, which protect the skin and stimulate collagen production, reducing wrinkles and maintaining skin elasticity. It also helps prevent high blood pressure thanks to its potassium content, which relaxes blood vessels and helps regulate sodium levels in the bloodstream. Not only does orange juice combat inflammation and reduce oxidative stress due to its anti-inflammatory properties, but it also supports the prevention of chronic diseases. Today, orange cultivation is one of the most prosperous industries worldwide. The leading producer of this fruit is Brazil, followed by India, China, Mexico, and the United States. Oranges, which belong to the Rutaceae family and the citrus genus, stand out among their relatives, a group that includes around 16 species known for their delicious, vitamin C-rich fruits. Successful cultivation of oranges requires a variety of techniques and careful maintenance, as environmental factors can significantly affect the plants and their fruits. This includes aspects such as morphology, size, color, texture, and the balance of acidity and sugar. The origin of the word orange traces back to the Arabic word naran. Sweet oranges are believed to have originated in southeastern China, and it is likely that the Romans introduced them to Europe. However, it wasn't until the early 15th century, after Marco Polo's travels to China, that Genoese merchants brought the cultivation of sweet oranges to Europe. Later, in the 16th century, the Spanish brought oranges to the Americas, starting in the United States and then spreading them to South America, South Africa, and parts of Australia. There is no doubt that orange juice offers many health benefits. However, it should be consumed in moderation, as excessive intake can raise blood sugar levels due to its high concentration of fructose. Typically, a single glass of juice contains the equivalent of 3 to 4 oranges, so it is best enjoyed as part of a balanced diet. As a result, a vast quantity of orange juice is produced daily. Did you know that over 20 million tons of peas are grown worldwide each year? This humble vegetable is not only incredibly beneficial for our health, But it also plays a key role in agriculture by improving soil and supporting ecosystems. Today, we are embarking on an exciting journey to uncover all the secrets of peas from the field to your table. You won't want to miss it. Peas are not only delicious but also highly nutritious. Thanks to their unique ability to fix nitrogen from the atmosphere, peas enrich the soil, making it more fertile for future crops. To grow a good harvest, peas require specific conditions. Plenty of sunlight, moderate rainfall, and well-drained soil, all of these are crucial for their growth. When summer arrives, it's harvest time. The process can be labor-intensive and may either be fully automated or require manual labor, especially when it comes to varieties of peas intended for fresh consumption. Depending on the size of the farmland and local traditions, different types of equipment are used to prepare the soil for planting peas. The planting process itself takes place in several stages. For peas to sprout and bloom, they need sufficient moisture, which is why seeders scatter the seeds across prepared beds. Irrigation methods depend on the type of soil, weather conditions, and water availability. Harvesting peas can be done by hand or through mechanization. On larger farms, combine harvesters are often used to speed up the process significantly. Specialized harvesting machines are equipped with pickup drums that gather the plants from the field and transport them to a threshing chamber. Inside this chamber, a rotating beater separates the peas from the plants. These mechanized harvesting systems can not only collect the peas but also clean them of leaves and stems right there in the field. After harvest, the peas are either sent directly for processing or go through additional cleaning and sorting. At the processing plant, the peas are placed into large receiving pits, where they undergo preliminary cleaning. From there, they are sent to a sorting line, where vibrating screens separate out any underdeveloped or damaged peas. Next, the peas are transferred to sizing machines, which sort them by size for further processing. The selected peas then move on to the washing stage, which involves several steps. An initial rinse to remove larger debris, followed by a thorough wash in tanks filled with water that is constantly filtered and refreshed to maintain cleanliness. After washing, the peas go through a blanching process, where they are briefly immersed in hot water. This step helps preserve their bright green color, retain nutrients, and improve texture. Blanching also eliminates any potential microorganisms. Afterward, the peas are rapidly cooled in cold water to halt the cooking process and maintain their freshness. Sorting is crucial to ensure only the best peas are selected. The washing process occurs on conveyor systems. First, the peas are rinsed to remove dirt, then they are submerged in specialized tanks for a more thorough cleaning. The water used for washing is often recycled and reused in the process. A crucial step for frozen peas is blanching. This process helps preserve their color, flavor, and nutritional value, while also killing bacteria and enzymes that could cause spoilage. After blanching, the peas are transferred to freezing chambers, where modern equipment rapidly lowers their temperature. This quick freezing prevents the formation of large ice crystals, helping to maintain the product's texture. Next, the peas are moved onto a conveyor belt for preservation. At this stage, they are placed into sterilized glass jars or metal cans. The peas are then covered with a hot solution made of water, salt, and sugar, which helps preserve their taste and texture over an extended period. After that, the jars or cans are sealed tightly and sent for sterilization, where they are exposed to high temperatures to eliminate any remaining microorganisms. This process ensures a long shelf life, without compromising the product's quality. Sterilization is one of the most crucial steps in the canning process. First, the jars containing the peas are heated to about 250 degrees Fahrenheit, which destroys harmful microorganisms and enzymes that could lead to spoilage. The sterilization process can last anywhere from 20 to 45 minutes, depending on the size of the jar and the density of the packing. Once sterilization is complete, the jars are quickly cooled to room temperature to prevent the glass from cracking due to thermal shock. This stage is essential for maintaining the integrity of the packaging and ensuring the product's quality. After sterilization, the peas go through a cooling phase to halt the heating process and avoid packaging ruptures caused by sudden temperature changes. Next, the canned goods move to the labeling line, where each can is marked with product information, expiration dates, and barcodes. To ensure transparency and ease of use, each can must include detailed information such as the production date, expiration date, and storage recommendations. This helps consumers feel confident about the quality and freshness of the product. After labeling, the cans are packed into cardboard boxes for transportation. At this stage, automated systems are used to place the cans in boxes with minimal manual handling, which speeds up the process and helps prevent damage. Once packaged, the cans are sent to a temporary storage warehouse before being distributed to retail locations. One of the final stages is quality control. Every step of the production process is closely monitored to ensure compliance with sanitary and technological standards. Specialized on-site laboratories regularly conduct tests to check the can's seal integrity, the presence of foreign particles, and organoleptic properties such as the taste, color, and smell of the peas. Only after passing all inspections is the product approved for shipment to the consumer. Smaller packages of peas are placed into cardboard boxes for further transportation. Automated systems and robotic arms tightly wrap each package in protective film and prepare it for shipment. Modern technology allows this entire process to be quick and efficient while maintaining high product quality. Special conveyor lines equipped with robotic manipulators carefully wrap each container in protective film, helping to prevent damage during transport and storage. Frozen and canned peas are shipped to supermarkets, stores, and markets. They are also used in the food industry to create ready-made meals. Logistics play a crucial role in maintaining the freshness of the peas. Frozen peas are transported in refrigerated trucks, while canned peas are shipped under conditions that prevent spoilage. For frozen peas, special refrigerated containers are used to maintain a constant temperature throughout the entire transportation process, which helps prevent spoilage and preserves their nutritional value. Canned peas are also transported with temperature control in mind to prevent packaging ruptures or the growth of microorganisms. Here are some interesting facts about peas. First, peas are one of the richest sources of plant-based protein among vegetables, making them an excellent choice for those who don't eat meat. 1 cup of fresh peas contains about 1/3 of an ounce of protein, which helps maintain muscle and overall health. Second fact, peas are high in fiber, which is essential for healthy digestion. Fiber promotes regular bowel movements and prevents constipation. Additionally, it supports the growth of beneficial bacteria in the gut, improving the microbiome and strengthening the immune system. Third fact, NASA has included peas in its list of plants suitable for growing in space. Their high nutritional value, ability to improve air quality through photosynthesis, and ease of cultivation make peas an ideal candidate for space missions, such as expeditions to Mars. Imagine a company at the center of a major scandal, but instead of fading away, it turns the challenge into an opportunity. Fairlife went from facing accusations of animal cruelty to becoming a leader in the dairy industry by implementing new ethical standards and winning back consumer trust. This is a story about how a crisis can become the starting point for positive change. Ready to learn how they managed to change the game and set new industry standards? Let's dive into this fascinating journey of transformation. Like any production process, Fairlife's manufacturing begins with collecting the main ingredient, milk. Fresh milk is sourced from farmers who adhere to high standards of animal welfare and product quality. Once the raw milk arrives at the plant, it undergoes the critical process of ultrafiltration. Ultrafiltration is a key stage in Fairlife's milk production that allows the separation of proteins, calcium, lactose, and other components. This process serves multiple purposes, removing some of the water from the milk, which makes the product more concentrated, significantly reducing the lactose content, making the milk suitable for people with lactose intolerance, and increasing the protein content by about 50% compared to regular milk. The ultrafiltration process is carried out using special membrane filters. These filtration systems utilize ultra-thin membranes through which the milk is passed under pressure, removing excess water and concentrating essential nutrients. After this, the milk moves into separators that help further divide the milk's components into different fractions. ensuring the right concentrations of protein, calcium, and fats are achieved. The next stage in Fairlife's production is fortification. This is the process of adding extra nutrients, such as vitamins and minerals, to the milk to boost its nutritional value. Common additives include vitamins D and A, calcium, and other beneficial components. These nutrients are introduced in either liquid or powdered form using special mixers. Before being added, the supplements are dissolved to ensure even distribution throughout the milk. Here's how the process works. Dosing devices calculate the required amount of additives based on the volume of milk being processed, which varies depending on the plant's capacity. The machine then measures the correct amounts of vitamins and minerals and introduces them into the ultra-filtered milk. Afterward, a giant mixer, known as a homogenizer, blends the liquid thoroughly to ensure even distribution of the additives, preventing clumping or uneven concentrations. Once mixing is complete, samples are taken for quality testing. This timely quality control step ensures that the nutrients are evenly distributed and meet established standards. The next stage is pasteurization. This is an automated process in which milk is treated at high temperatures to eliminate harmful bacteria while maintaining its freshness and nutritional value. Honestly, I was amazed at how much happens at the plant. You might think it's as simple as getting the milk from the farmer, bottling it, and that's it, right? But meanwhile, the ultra-filtered and fortified milk flows through pipes into the pasteurization block, where it pours into prepared containers. In the pipes, the milk passes through heat exchangers, where it's quickly heated by hot water or steam to 170 degrees Fahrenheit for 15 to 20 seconds. This quick heating process kills most pathogenic organisms. As for the remaining few, well, nothing is ever 100% sterile, just something to live with. After heating, the milk is rapidly cooled to about 40 to 42 degrees Fahrenheit, which helps preserve its freshness and prevents bacterial growth. The cooling happens in the same exchanger, but this time using cold water that circulates around the pipes. The pasteurized milk is then transferred into sterile storage tanks, where it waits until it's ready to be packaged. The finished milk is packaged into special airtight containers that ensure freshness and long-term storage. By the way, here's a personal tip. Always check the seal of the packaging before you buy it. Once, I failed to do this while visiting my parents for a family dinner, and let's just say the upstairs bathroom got a lot of use. But that's another story. After pasteurization, the milk is transferred from storage tanks to the conveyor belt through pipelines. There, it enters an automated packaging system that controls the entire process. On the packaging line, machines automatically supply and form either cardboard or plastic containers. The packaging is sterilized with ultraviolet light or steam to kill any potential microorganisms. Fairlife milk is dispensed into the prepared containers by high-precision dosing machines, ensuring that each container receives the exact same volume. Once filled, each container is hermetically sealed to prevent air from entering and to maintain the milk's freshness. Depending on the type of packaging, sealing is done using either adhesive or heat. After the containers are securely sealed, important information like the production date, batch number, and expiration date is printed. This labeling is done directly on the packaging line using either a laser or inkjet printer. The packaged containers go through automated sensors and cameras, which check for defects, proper sealing, and compliance with standards. Once inspected, individual containers are grouped into larger bundles or boxes for easier transportation. Robotic systems swiftly and accurately assemble these group packages. The finished bundles are then automatically stacked onto pallets, ready to be stored in the warehouse or sent directly to retail locations. I swear, friends, I've never seen packaging quite like Fairlife's anywhere else. It's so futuristic. It stands out from regular milk cartons as if it was dropped straight from a spaceship onto your table. Fairlife processes millions of gallons of milk each year to meet the demand for its products in the United States and other countries. Thanks to ultrafiltration, Fairlife milk contains 50% more protein and 30% more calcium compared to regular milk. Each serving of Fairlife provides approximately 13 grams of protein per glass, making it popular among people who follow a healthy lifestyle. Fairlife is actively promoted as a healthier alternative to regular milk due to its high protein content and reduced sugar levels. The company works with small family farms, ensuring high-quality milk and supporting the well-being of farming families. Thanks to its specialized processing, Fairlife milk has a longer shelf life, up to 90 days, compared to regular milk. The company emphasizes environmental responsibility by using technologies that reduce water and energy consumption during production. Fairlife quickly became one of the leaders in the ultra-filtered milk market thanks to its innovative approach. However, the company found itself in the spotlight after allegations of animal cruelty at its supplier farms surfaced. In response, Fairlife took action to improve animal welfare and implemented new standards for monitoring its farming partners. The company is actively working to regain consumer trust by introducing initiatives aimed at enhancing animal well-being. Fairlife continues to expand its product line, adding flavored milk options, yogurts, protein drinks, and other dairy products. Have you ever wondered how simple ingredients come together to create 100 tons of the legendary Nutella? We start with 20 tons of hazelnuts from Turkey, 15 tons of sugar, and 10 tons of cocoa from Ghana, transforming them into a flavor loved by millions. From the chocolate shortages during the war to millions of jars on store shelves today, are you ready to discover how the magic happens at each step? Let's dive in. Nutella was created in Italy during World War II when chocolate was in short supply. Confectioner Pietro Ferrero mixed hazelnuts with chocolate to create a more affordable product. Originally, his recipe was called pasta gianduja, but it was eventually transformed into Nutella, which was released in 1964. Today, this chocolate hazelnut delight is available to everyone, and I'm here to walk you through the entire process, from cocoa beans in Ghana to the finished product on store shelves. Let's start with an analysis of the production plans. Here are some numbers for you. If 100 tons of Nutella are planned for production, we need to calculate the required amount of ingredients. That means around 20 tons of hazelnuts, 15 tons of sugar, 10 tons of cocoa powder, 8 tons of palm oil, 5 tons of powdered milk, and 440 pounds of vanilla. The ordering process with our trusted suppliers begins, usually from Turkey, Africa, Malaysia, and our local farms. The purchase order is based on analytical forecasts, aiming to optimize the production process and maintain top-quality raw materials. For example, 20 tons of hazelnuts are ordered 2 months before production to ensure they are fresh. Next comes the logistics. Every detail must be carefully planned since the raw materials are sourced from different corners of the world. Hazelnuts are shipped from Turkey, cocoa powder comes from Ghana, and palm oil makes its way to our warehouses by sea from Malaysia, which means transportation can take about 4 to 6 weeks. Once the goods arrive, the raw materials are stored in dry, dark facilities with strict temperature controls kept between 59 and 68 degrees Fahrenheit to prevent spoilage and oxidation. Detailed record-keeping of each batch is also essential, ensuring that we can trace their origins and meet food safety standards. This step is crucial for maintaining the high quality of the final product and adhering to environmental and ethical standards. Even though the hazelnuts are shipped in specialized containers to prevent damage, they undergo a thorough quality check before processing, just like the other ingredients. This involves using contactless sensors that measure moisture levels and temperature upon receipt. The moisture content must not exceed 8%. Additionally, a visual inspection is carried out using high-resolution cameras that detect defective nuts and any foreign particles. If defects are detected, the system automatically separates them. The hazelnuts are then cleaned in automated cleaning machines, with each batch handling 1 ton of hazelnuts at a time. The process takes around 30 minutes, during which air streams remove the skins and other light particles. Quality control is maintained through sensors that monitor airflow speed and adjust the intensity of the cleaning process in real time. The cleaned hazelnuts are then automatically transferred to roasting ovens. We set the temperature between 320 and 360 degrees Fahrenheit and wait for about 15 to 20 minutes. The ovens are equipped with automated thermal sensors that monitor temperature and humidity levels. If the humidity exceeds 1%, the system automatically adjusts the roasting parameters. After roasting, the hazelnuts are moved into cooling chambers, which ensure rapid cooling to room temperature between 68 and 77 degrees Fahrenheit. This cooling process takes approximately 30 minutes. The chambers are also equipped with sensors to maintain consistent temperatures for even cooling. Next, the hazelnuts go into automated grinding machines with a capacity of up to 2 tons at a time. The grinding process takes about 10 to 15 minutes. These machines are equipped with control systems that ensure the desired paste consistency is achieved. The key objective is to reach a 50% oil content, which is essential for achieving a smooth texture. Do you smell that? I call it the scent of magic, when a few simple ingredients transform into a flavor everyone knows. Now, we're moving on to the mixing process, so let's take a closer look at how it all happens. In large mixers with a capacity of up to 30 tons, all the ingredients are loaded in. These mixers come equipped with automatic speed controllers, allowing the blade rotation speed to be adjusted based on the consistency of the mixture. We set the speed to 60 revolutions per minute and wait about 20 to 30 minutes for the process to finish. During mixing, it's crucial to monitor the temperature, as it affects the final texture of the product. The mixers are equipped with temperature sensors that automatically adjust cooling if the temperature exceeds 86 degrees Fahrenheit. Workers receive real-time temperature data, allowing for quick adjustments whenever needed. An essential process we'll discuss now is emulsification. Emulsifiers in Nutella play a key role in ensuring a smooth texture, preserving flavor, and extending the product's shelf life. For emulsification, an automated system is used for precise dosing of emulsifiers, which typically make up about 1 to 2% of the total mixture. A common choice is soy lecithin. The system ensures accuracy up to 0.1%, which is critical for the stability of the final product. The prepared mixture is then loaded into automated emulsifiers with a capacity of up to 30 tons. The emulsifier is equipped with paddle stirrers that can operate at speeds of up to 1,000 revolutions per minute, enabling rapid and efficient mixing. It's crucial to monitor the temperature of the mixture, which should not exceed 105 degrees Fahrenheit to prevent oil breakdown and preserve flavor. To maintain this, the emulsifier is equipped with thermostats. If the temperature starts to rise, the system automatically activates cooling elements, keeping the conditions optimal. During emulsification, workers monitor the viscosity of the mixture using automated sensors. The ideal viscosity for Nutella is about 20 to 30 pascal-seconds. If the viscosity is too high or too low, the system automatically adjusts the mixing speed or adds oil to achieve the desired consistency. After the emulsification process is complete, about 30 tons of finished mixture is produced, with a temperature of around 105 degrees Fahrenheit. This temperature helps maintain the uniformity and texture of the emulsion. The finished mixture is automatically pumped into cooling tanks. The system has a capacity of around 265 gallons per minute, allowing for rapid processing of large volumes. The cooling tanks are equipped with automated cooling systems that can bring the temperature down to 68 degrees Fahrenheit within 30 to 40 minutes. Temperature is monitored in real time, using sensors to maintain stability throughout the entire process. During the cooling stage, the moisture content of the emulsion is also carefully monitored. The ideal moisture level should not exceed 5%. If the humidity is higher than the standard, the system automatically activates dehydrators to remove excess moisture. This step is crucial for ensuring a longer shelf life for the product. The finished Nutella is automatically pumped into filling machines using pumps with a capacity of up to 265 gallons per minute. The filling machines automatically portion the Nutella into jars with a volume of 14 ounces. Each jar weighs about 1 pound, including the packaging. The system ensures accurate filling with a tolerance of up to 1%, achieved through automated scales that weigh each jar during the filling process. After filling, the jars pass through an automated capping machine. It uses airtight lids to ensure long-term freshness, and the machine can cap up to 600 jars per hour, enabling the efficient processing of large volumes. Next, the jars are labeled using an automated labeling machine, which can label up to 500 jars per minute. Before starting the process, it's essential to check that the label hopper is stocked with enough labels. Each label includes information about the product, ingredients, expiration date, and barcode. Labels are applied with an accuracy of 0.02 inches, thanks to sensors that monitor the position of the jars on the conveyor belt. The system automatically checks for proper label placement and detects any defects, such as misalignment or missing labels. If the system identifies an issue, it automatically halts the machine, preventing errors in production. After labeling, the jars are automatically transferred to the packing machine. Here, they are arranged into cardboard boxes, with 12 jars per box. The packing process operates at a speed of up to 300 boxes per hour. The boxes are formed automatically without the use of glue, utilizing specialized mechanisms that ensure both speed and reliability. During packing, the system monitors the proper arrangement of jars within each box. If a box is missing jars, or if they are incorrectly placed, the system triggers an error alert. Each box is equipped with internal dividers to prevent damage to the jars during transportation. The finished boxes are then automatically fed onto a conveyor where they are stacked onto pallets, typically with about 100 boxes per pallet. Each pallet is labeled with information about its contents, making subsequent storage and transportation easier to manage. After the packing process is complete, the quantity of finished Nutella pallets is checked, usually around 200 pallets per day, with each pallet holding 100 boxes containing jars of Nutella, each with a volume of 14 ounces. An automated warehouse management system generates routes for forklifts, which transport the pallets throughout the warehouse. In the loading zone, specialized hydraulic lifts come into play, automatically raising pallets to the height of the truck's cargo area. Typically, a single truck can hold up to 30 pallets. Each truck is provided with automatically generated labels that include information about the contents, production date, expiration date, and final destination. The trucks then head out to distribution centers located up to 500 miles from the plant. The transportation status is monitored through a GPS system, allowing real-time tracking of each vehicle's location. When a truck arrives at the distribution center, the pallets are scanned again to confirm receipt, and they're then prepped for their next journey to supermarkets and into the hands of eager customers. Did you know that over 10 million cakes are produced worldwide every day, with ingredients traveling from every corner of the globe? In this video, we'll dive into the fascinating world of massive conveyor belts and fully automated production lines, where simple ingredients are transformed into sweet masterpieces in just minutes. Get ready to uncover the industry secrets you never knew existed. Cake factories in the United States and worldwide purchase ingredients in volumes that match the scale of their production. They typically sign contracts with large ingredient suppliers, such as producers of flour, sugar, butter, eggs, dairy products, and flavorings. These suppliers can deliver consistent, large-scale shipments and often adhere to strict quality standards, which is crucial for maintaining the taste and quality of the final product. Core ingredients like wheat flour are usually bought from large manufacturers or cooperatives, while specialized ingredients like flavorings or colorings may be sourced from specialty companies. Logistics companies deliver these products directly to factories, often in refrigerated or sealed containers to keep everything fresh. Some ingredients like chocolate or exotic fruits are imported from producing countries, chocolate from Latin America for instance, since this can offer better quality or pricing compared to local sources. Imagine that the ingredients in your dessert might have traveled from nearly every part of the world. Modern cake production is fully automated, with ingredients added to the mixer via conveyor systems and dispensers, requiring no human intervention. For instance, dry and liquid ingredients are added using dosing and weighing systems. Each ingredient comes from its own container, fed through automated pipes or funnels that accurately measure and deliver the required amount into a large industrial mixer. Flour, salt, and sugar are dispensed from bins or containers through piping systems. They pass through dispensers that precisely control weight and quantity before being moved on a conveyor to the mixer. Butter, milk, water, and eggs are fed through special pump systems that control liquid flow, connected to dispensers that automatically add the exact amount of liquid ingredients into the mixer. At large factories, eggs are often used in the form of pasteurized liquid egg mixtures, stored in refrigerated containers. When whole eggs are needed, they are automatically cracked by special machines, with the shells separated, leaving just the egg mass for mixing. All these ingredients are then combined in the large mixer for blending. After mixing, the batter is directed to specialized dosing and filling machines that precisely measure and dispense it into baking molds. The batter from the mixer travels through a conveyor or pumping system to the dosing station. A holding tank or container is used to store the batter temporarily for convenience until the next step. Pumping equipment regulates the batter flow to ensure smooth, continuous transfer. At this stage, the dispenser carefully measures the batter volume that will be distributed into the molds. Dosing mechanisms are set to provide each mold with the exact amount of batter, which is crucial for achieving consistent cake sizes. Some systems use volumetric dosing, which measures batter by volume, or weight-based dosing to ensure the precise weight of each product. An automatic filling head distributes the batter into pre-arranged molds on a conveyor. As the molds move under the dosing head, the filling mechanism releases the required amount of batter directly into each one. These molds may be round or rectangular, depending on the product type. To avoid overfilling or underfilling, dispensers are equipped with a feedback system that adjusts batter amounts based on weight or volume data. Some filling machines have sensors that monitor filling levels and automatically stop once the correct amount of batter is reached. After the batter is poured into molds, the conveyor moves them into specialized industrial ovens. In large-scale production, tunnel ovens are used, where the conveyor with molds passes continuously from one side to the other. The baking temperature and time are carefully calibrated for each type of batter. These ovens are preheated to specific temperatures, typically ranging from 302 to 356 degrees Fahrenheit for cakes. The ovens maintain a steady temperature and control humidity levels, with modern models equipped with automatic temperature control systems to ensure even baking. It's crucial to maintain consistent heat distribution and optimal moisture levels during baking. Industrial ovens are often equipped with steam injection or ventilation systems to manage humidity, helping to create the perfect crust and texture for the cakes. The conveyor moves at a speed that allows each product to bake for the optimal amount of time, typically 20 to 30 minutes. Tunnel ovens feature adjustable temperature zones, so the batter rises at the beginning of baking and achieves an even color and texture by the end. This automated process allows for the simultaneous baking of thousands of cakes. After baking, the conveyor moves the molds with freshly baked cakes onto a cooling line, where they rest to stabilize their temperature. This step is crucial to prevent deformation and ensure perfect texture. Cooling usually happens via fans that blow cool air over the cakes. As soon as the cakes exit the oven, the conveyor transfers them onto a designated cooling line. At this stage, the cakes are still very hot, so gradual cooling is essential to prevent cracking. On the cooling line, fans or air conditioning systems blow cool air evenly over the cakes. The fans operate at multiple levels to cool the cakes uniformly from all sides, avoiding sudden temperature changes. I have to say, after my air conditioner broke this summer, I could have really used a tour like this to escape those 2 weeks without cool air. Some factories use spiral coolers, which are conveyors coiled in a spiral, allowing cakes to move upward and cool gradually along the way. This design saves space and provides ample time for gradual cooling, perfect for high-volume production. To prevent excessive drying, the cooling areas maintain an optimal humidity level. Some cooling systems even allow humidity adjustment to prevent the cake surfaces from drying out and to keep them looking fresh and appealing. Once the cakes are cooled, they move along the line where they are prepared for filling. All the necessary ingredients for the cream, such as buttercream, ganache, or other types of fillings, are pre-prepared and stored in large barrels or tanks. Automatic pump systems allow the cream to be transported directly from the tanks to the application area. This shortens the processing time and reduces the risk of contamination. The pumps maintain the required pressure so that the cream flows smoothly to the filling machines. The cakes are then lifted onto a special conveyor with a mechanism that has small fingers to gently hold each cake in place. Automatic machines apply the cream on the top of each cake, typically using sprayers or nozzles that distribute the cream evenly over the surface. If the cake has multiple layers, the mechanism automatically separates the cake into layers, applying cream between each one. This process also happens via conveyors that move each layer to the cream applicator and then return it to its original position. Fascinating, isn't it? After filling, the cake proceeds to the assembly stage. Here, special systems pick up each layer one at a time and stack them in the correct order. The machines may use different mechanisms, such as tongs, suction devices, or other technologies, to assemble the cake precisely without damaging it. Now comes the most exciting part: decorating the finished cakes. This is the stage that almost makes my mouth water, as it's nearly impossible to stay calm watching such artistry in action. After assembly, the cakes move to the decorating line. All the necessary materials, such as creams, glazes, fruit fillings, and other decorations, are prepared in advance and stored under controlled conditions. The cakes travel on a conveyor to a machine that automatically applies the glaze. This can be done using sprayers or injectors that form an even layer of glaze over the cake's surface. Next, a decorative pattern may be applied to the cake. This is achieved with special sprayers that create intricate designs using cream or glaze. Stencils or specialized machines may also be used to create embossed patterns automatically. Various decorative elements can be added to the cakes, including berries, nuts, chocolate pieces, sugar flowers, and other embellishments. Automated systems or robotic arms can carefully place these decorations, ensuring they're evenly distributed for a visually pleasing effect. During this stage, final touches like sprinkles of chocolate shavings, powdered sugar, or other toppings can also be added. Once decoration is complete, the finished cakes are transferred to an automated packaging line. Here they may be packed into boxes, wrapped in protective film, or otherwise prepared for transport. Over 28 million short tons of olives are harvested every year, each one playing a role in the creation of olive oil, liquid gold. From ancient traditions to cutting-edge technology, this video will reveal the secrets behind producing the oil that has shaped civilizations. I visited one of the world's leading factories to bring you this story. At modern industrial facilities, collaboration with agricultural producers is essential. Experts study the ripeness of the olives to determine the perfect time for harvest. There are two main methods for doing this. In some regions, they still use traditional techniques where workers gently strike the branches with sticks so the olives fall into nets spread out on the ground. However, on large farms, you'll often see vibrating machines that shake the trunks, causing the olives to drop into upside-down containers positioned around the tree. Once the olives are harvested, they are quickly transported to the mill for further processing. Speed is crucial since olives begin to spoil immediately after being picked. Ideally, no more than a day should pass between harvesting and processing. When the trucks arrive at the plant, they unload the olives into large receiving bins. This is where the quality control stage begins, with samples taken to assess the condition of the olives, their ripeness, and to check for any defects or diseases. The olives then go through a cleaning process to remove leaves, branches, stones, and other unwanted materials. Ventilation systems and vibrating screens are used to effectively separate these elements. After dry cleaning, the olives are rinsed in cold water to remove any dust, dirt, or impurities that could affect the quality of the oil. Crushing is the process of breaking down the olives to extract the oil contained in their cells. In modern mills, this is done using hammer mills or metal discs that rotate at high speeds. The crushed mixture includes not only oil, but also the plant liquid from the olives, along with solid pieces of pulp and pits. This mixture, known as olive paste, is the primary substance used to produce oil. The paste is then transferred to malaxers, where it is gently mixed to break the emulsion of water and oil, making the separation process easier. Mixing occurs at a precise temperature, typically between 80 and 84 degrees Fahrenheit. There are two main methods for extracting the oil: the traditional pressing method and continuous centrifugation. The traditional method, although less common, involves pressing the olive paste using fibrous discs called mats. In the continuous centrifugation method, the difference in density between the oil, water, and solid particles is used. The paste is placed in a high-speed horizontal decanter, which spins rapidly, separating the components. The oil extracted through centrifugation contains tiny suspended particles and traces of water. To remove these, a natural separation process takes place in stainless steel tanks. Many industrial facilities also use vertical centrifuges to more efficiently separate the smallest water particles and remaining solids. Packaging is done on automated lines that quickly fill, seal, and label bottles or cans. To protect the oil from light, it's best to use opaque or tinted materials, such as dark glass or cans. During bottling, strict quality control is carried out to ensure accurate weight, proper sealing of caps, and correct labeling, as well as to detect any potential defects. Throughout the entire process, physical, chemical, and sensory quality checks are performed to determine the final grade of the oil. Olive oils are divided into three categories: extra virgin olive oil, which is of the highest quality with an acidity level below 0.8% and no sensory defects; virgin olive oil, characterized by good quality with a maximum acidity of 2% and minor sensory defects; and lampant olive oil, which is not suitable for direct consumption and requires refining. Around 6,000 years ago, in the Middle Eastern region, the first evidence of olive oil production was discovered. In the lands that are now part of Syria, Lebanon, and Israel, early agricultural pioneers recognized the potential of this unique fruit. Initially, the process was simple but labor-intensive. Olives were crushed with stones, and the oil was then separated through decanting. Before long, this precious golden nectar became a highly sought-after commodity, not just for its nutritional value, but also for its healing and ceremonial properties. The Phoenicians, skilled in maritime trade, were responsible for spreading the olive tree and its valuable oil throughout the Mediterranean, sailing from port to port and coast to coast. The olive tree took root in unfamiliar lands. In ancient Greece, the olive tree gained an almost legendary status. According to tradition, the goddess Athena gifted this miraculous tree to the city of Athens. In ancient Greece, athletes who won the Olympic Games were honored with olive wreaths, and soldiers were given ointment made from the same tree to prepare them for battle. The Romans, heavily influenced by Greek culture, took olive cultivation to a higher level. They developed innovative methods for growing and harvesting olives, and expanded olive groves across their vast empire. In the Roman world, olive oil became a staple fat, symbolizing the sophistication and refinement of Roman culture. Beyond its culinary uses, olive oil was revered for its healing properties. Hippocrates, known as the father of medicine, prescribed it for a variety of ailments. In earlier times in Rome, Galen, a physician famous for treating gladiators and emperors, incorporated olive oil into his medicinal ointments. Before the discovery of oil, olive oil played a crucial role as a source of light. For many years, oil lamps illuminated homes, religious buildings, and reading rooms, literally fueling the light of knowledge and culture. During medieval times, monasteries were responsible for preserving the ancient tradition of tending to olive groves and producing oil. In their fields and manuscripts, they cared for olive trees and refined cultivation techniques. When the New World was discovered, the olive tree journeyed across the seas. Adventurers from Spain and Portugal brought olive tree cuttings to the Americas, planting the first olive groves in Mexico, Peru, Chile, and California. Olive oil, especially extra virgin, is rich in beneficial nutrients like monounsaturated fats and antioxidants, which help support heart health by lowering harmful cholesterol levels and reducing inflammation in the body. Research shows that regular consumption of olive oil can reduce the risk of cardiovascular diseases and strokes by improving circulation and helping to maintain healthy blood pressure. It also has a positive effect on digestion, promoting better absorption of nutrients and preventing stomach issues. And finally, we'd like to share a few lesser-known facts about olives and olive oil. The oldest olive press was discovered on the island of Crete and dates back more than 3,500 years. It was so advanced that it used principles similar to modern methods. Olive oil doesn't spoil as quickly as many believe. When stored properly in a cool, dark place, it can retain its properties for up to 2 years. Olives of different colors aren't different varieties. Green and black olives are the same fruit. Green ones are harvested earlier, while black olives are left on the tree to ripen longer. Did you know that a banana isn't actually a fruit from a tree, but rather a type of giant grass? And a single bunch can weigh up to 110 pounds? From tropical plantations to your table, join us as we uncover the amazing secrets behind the banana's journey and learn about the technologies that make it all possible. In the world of fruits, there is one true king, essential to breakfast, dessert, or any afternoon snack. This fruit is not only delicious, but also incredibly nutritious, with a history that goes back centuries. Yes, you guessed it, we are talking about bananas. But do you know where they come from? And the journey they take from seedling to your plate? I traveled to the tropical regions where bananas are grown, ranging from Latin America to Southeast Asia. Each region has its own unique methods and traditions for cultivating these green treasures. Today, I'm excited to share with you the fascinating process behind it all. Sunrise on a banana plantation marks the start of another hardworking day. Here, among endless rows of greenery, begins the story of every banana that will eventually make its way to your table. Bananas aren't trees in the traditional sense of the word. They are the largest herbaceous plants, producing fruit in bunches that can weigh up to 110 pounds. Growing such a marvel of nature requires not only knowledge and experience, but also incredible care and attention. Caring for banana plants starts with planting seedlings and continues all the way through to harvest. Farmers regularly inspect the plants for pests and diseases, ensuring they receive the right amount of water and nutrients. Modern technology plays a key role in banana cultivation. From drip irrigation systems to drones used for monitoring plant health, these innovations help increase yields while reducing the environmental impact. It all begins in the fields, where the meticulous work of planting banana seedlings and preparing the soil takes place. I watched as farmers used cultivators to carefully place the seeds in the optimal spots and gently watered the seedlings with a fine mist or spray. The maturation period for banana plants can range from 9 to 20 months, although some varieties develop faster than others. As the plants mature, special agricultural techniques are applied. For instance, farmers trim the tip of the banana bud to stimulate the development of the bunch. To speed up the formation of banana clusters, they also remove some of the female flowers. Over time, these clusters grow into mature bananas. At this stage, disease management becomes crucial. Common banana leaf diseases, such as Xanthomonas wilt, Fusarium wilt, and black or yellow sigatoka, are combated by removing infected leaves and using pesticides. These treatments are essential to protect banana crops from pests and ensure a healthy harvest. Harvesting bananas is truly an art that requires precise timing based on visual cues, such as the size and ripeness of the banana. During this time, workers also monitor the growth of pups, young banana plants that sprout from the roots of older plants, to ensure they stay healthy. I watched as workers carefully cut each bunch from the vine, taking great care not to damage the fruit. Once the bananas are harvested, they are sent to processing areas. The bunches are tied together and transported via a conveyor system to a washing station. During the washing process, bananas are cleaned of harmful bacteria and debris to prepare them for further processing. For transport, they are protected by cotton paper, which is placed between each row of bananas to keep them safe during their journey. Bananas are highly perishable, so quick preparation is essential. When I arrived at the banana processing plant, I was shown the entire preparation process. First, the bananas are rinsed with water, measured, and the protective cotton paper is removed. Before they are packaged, the bananas are cut into smaller bunches and washed one last time to ensure they are completely clean. Workers then use scissors to cut the bunches into sections, check the weight, and prepare them for distribution before moving them to the packaging line. This precise procedure highlights the level of care and attention required to ensure bananas remain fresh and high quality throughout their journey from the field to the consumer. The transportation and storage of bananas is a complex process that requires close monitoring at every step. After harvest, the bananas are carefully packed into boxes to prevent damage. They are then transported in special temperature-controlled containers to avoid premature ripening. During transportation, often by sea, the bananas are kept at an optimal temperature of around 55 degrees Fahrenheit. Upon arrival at their destination, bananas go through a ripening process in specially equipped chambers. Here, the temperature and ethylene concentration are carefully controlled to ensure the bananas ripen evenly before they reach store shelves. This process allows the bananas to develop their characteristic yellow color and desired softness. In stores and markets, bananas are kept at room temperature, away from direct sunlight and ethylene-producing products, to minimize further ripening and extend their shelf life. This helps ensure that the bananas remain fresh and flavorful until they reach the consumer. At the same time, there is a dedicated section of the factory for producing banana chips. Banana chips are a tasty and popular snack made by drying or frying thinly sliced pieces of banana. They can be made from either ripe or unripe bananas, depending on the desired flavor and texture. I watched as bananas were peeled by hand to remove the fruit. Banana chips, made from either mashed or sliced bananas, are fried in hot oil and turn out incredibly delicious. Once the chips are fully cooked, they are placed on a draining tray to remove excess oil, ensuring they have a perfectly crispy coating. The dried chips are seasoned with spices to make them even more flavorful. The factory staff carefully plan each step before sending the chips to the packaging area, which is managed by an artificial intelligence-powered machine. Before placing the chips into plastic bags, the machine takes precise weight measurements. Once the workers finish filling the bags, they place them into paper containers and seal them with the company's branding. These containers display important information, including the serial number, production date, and expiration date. The containers are then securely sealed with tape, ensuring the chips are safe for transport and storage. This comprehensive process, starting from banana cultivation and ending with banana chips and market-ready packaging, highlights the significant effort and technology involved in preparing these products for sale or export. It offers an interesting glimpse into the banana processing industry, showcasing the intricate procedures used to preserve the freshness and high quality of bananas from harvest to final sale. Banana chips are a source of nutrients like potassium, B vitamins, some dietary fiber, and minerals, especially when they are dried. However, fried banana chips can contain a considerable amount of fats and calories, so they should be eaten in moderation. You can also make banana chips at home, where you can control the amount of oil and seasoning added, making them a healthier option compared to store-bought varieties. The next time you grab a banana, take a moment to think about all the effort that went into its cultivation, harvest, and delivery. Remember that each bite connects you to distant countries, cultures, and people who make this world so vibrant and diverse. Imagine if every glass bottle you throw away could become the key to saving the planet, and even earn you some extra cash. Did you know that over 130 million tons of glass are recycled worldwide each year? I recently visited one of the largest recycling plants to uncover the fascinating secrets of how ordinary glass takes an incredible journey from the trash bin to new possibilities, transforming our lives along the way. So, how does a glass item get a new life? The recycling process for bottles begins with collecting used glass. In many cities and countries, a system of separate waste collection is in place. which greatly helps with efficient recycling. Special containers for glass collection are set up in various locations, separated from those for plastic, paper, and organic waste. This prevents glass from mixing with other materials, making the recycling process smoother. In some countries or companies, glass collection points have been established, where people can return used bottles and receive a reward in exchange. This encourages the public to participate in gathering and returning glass bottles for recycling. In many former Soviet Union countries, the collection of glass is often carried out by vulnerable and marginalized groups. However, in European Union countries, it is a routine practice for everyone to return used containers, often receiving something like a discount on their grocery bill in return. Once collected, the glass is sent to recycling plants, where the main processing begins. Once the glass bottles are collected from containers or drop-off points, they are transported to specialized sorting centers for further processing. Waste collection trucks periodically pick up the glass from these containers and deliver it either to sorting centers or directly to recycling plants. This is typically done on a large scale to make transportation more efficient. At the plants or sorting stations, the trucks unload the glass bottles into large containers, where they begin the preparation process for sorting and recycling. Once the bottles arrive at the facility, the next step begins, sorting the glass by type and color. This step is crucial to optimizing the recycling process. Sorting glass by color is extremely important because different glass colors are used for different products, and mixing them can reduce the quality of new items. The bottles are sorted automatically using special optical scanners that detect the glass color and sort it into clear, green, and brown categories. This is crucial since each type of glass requires separate recycling processes. These sorting machines are equipped with sensors that identify the color of the glass using light sensors. Whole bottles or glass fragments move along a conveyor belt, where machines illuminate them with a lamp or laser. The light reflected from the glass is analyzed by the sensors. The system identifies the glass color based on the signal received and sends this information to a controller. After identifying the color, each glass piece is directed to the appropriate section, either through a stream of air or mechanically removed from the conveyor. The glass is then separated into different streams, which significantly simplifies the next steps of melting and reuse in new products. Once sorted by color, the glass passes through magnets and air streams to remove metal elements like bottle caps, as well as other impurities such as paper labels or plastic residues. Powerful magnets are placed along the conveyor belt to capture all metallic impurities, including steel caps, while electromagnetic separators are used to remove aluminum caps and foil pieces. Pneumatic systems are used to blow away plastic and label remnants from the conveyor, using strong air currents to clear away any materials that are not needed for further recycling. Of course, the glass also undergoes a wet cleaning process in special washing systems, as many of these bottles will be reused to make containers for food products. Just think about it. We discard bottles without a second thought, not realizing how much effort goes into recycling them. Compared to other materials, glass does not wear out or degrade with use, making it an incredibly sustainable material for continuous recycling. After the sorting process, the glass is crushed into what's called cullet, which serves as the raw material for making new glass products. Specialized machines are used to break down glass bottles into small pieces, making further processing easier. These crushers come in various types, but most work using a mill with two parts, one stationary and one movable, where the glass is ground down as the two parts rub against each other. Crushers can include jaw, cone, roll, hammer, and gyratory types. The glass is fed into the crushing machine via a hopper or conveyor belt, and inside, mechanical elements reduce it to the desired size. Some crushers go through multiple stages of crushing to ensure uniform particle size. At this point, any remaining impurities that were not removed during sorting can be further filtered out. After crushing, the cullet is sifted to remove pieces that are either too large or too small. This is done to ensure a uniform mixture of cullet that's ready for melting. From this finely crushed cullet, new bottles and jars are most often produced, It can be a bit unsettling to think that something made from waste ends up as new tableware, right? But the powerful processing and extremely high temperatures used in recycling leave no chance for the glass to carry any trace of its former life into the finished product. After being crushed, the cullet undergoes further cleaning to remove any remaining contaminants and is treated before heading to the melting furnaces, starting with magnetic separation. This process eliminates any leftover metals that may have passed through the sorting phase. It's crucial because even small traces of metal can disrupt the glass melting process. Next, specialized technologies are used to remove any organic residues, such as paper labels, adhesives, or other materials, ensuring that the cullet is completely clean before melting begins. The glass fragments are then sent to vibrating sieve machines, where they pass through screens of various sizes to separate the cullet into different grades based on particle size. Different grain sizes are used for different glass products. At this stage, the entire process is automated, with machines equipped with monitoring and control systems. The use of specialized machinery also reduces the risk of injury for workers handling glass bottles, as the entire process takes place in a controlled and safe environment. After being cleaned, cullet is sent to recycling plants, where it is transformed into new molten glass. At the plant, the cullet is loaded into special furnaces, where it melts at temperatures ranging from 2,800 to 3,000 degrees Fahrenheit. The glass becomes liquid and ready to be shaped into new products. Adding cullet to the melting process reduces energy consumption, as recycled glass melts at a lower temperature than raw materials. Occasionally, new raw materials such as sand, soda ash, and limestone are added to the melting process to maintain the chemical composition and quality of the glass. This helps ensure the strength and clarity of the new products. Once the glass is transformed into a molten state, it is used to produce new glass items. The liquid glass is poured into molds to create various products such as new glass bottles, jars, vases, or other containers. Lower quality recycled glass is often used as filler in concrete, which enhances its aesthetic appeal, increases strength, and improves thermal insulation. In large factories, this process is fully automated and may involve high-precision molds to ensure the desired quality and thickness of the glass. After shaping, the glass products pass through specialized cooling systems, where the temperature is gradually reduced. This step is crucial to prevent cracking and ensure the mechanical strength of the finished products. After forming, the new glass products undergo rigorous quality control to ensure they meet safety and durability standards. Optical and mechanical tests are conducted for this purpose. Specialized systems inspect the products for defects such as air bubbles, cracks, or improper shapes. If a product does not meet the required standards, it is sent back for recycling. Additionally, the items are tested for mechanical strength, especially in the case of glass bottles, which must withstand pressure and other stresses during use. Once all stages are complete, the new glass products are packaged and transported to the market for further use. In large factories, the packaging process is also automated. Glass products are grouped and packed into cardboard boxes or placed on pallets for easy transportation. The finished goods are then shipped to warehouses or directly to customers, such as beverage, food, and other product manufacturers, where they will be used again, allowing the glass recycling cycle to start anew. This process is both economically and environmentally beneficial. Glass recycling plays a significant role in reducing greenhouse gas emissions and water pollutants. By using recycled glass material to produce jars and containers, we can minimize waste and lower our carbon footprint. Additionally, producing glass from raw materials requires extraction methods that negatively impact the environment, making recycling a much more sustainable choice. Glass recycling offers significant environmental benefits due to its energy efficiency. Using recycled glass, cullet, helps reduce energy consumption in the production of new products, as melting cullet requires lower temperatures than melting raw materials. Researchers in this field have noted that energy use can be reduced by 3%. Recycling also decreases the amount of waste sent to landfills. since glass does not naturally decompose and can remain in the environment for thousands of years. Recycling it is crucial for environmental preservation. Additionally, glass recycling conserves natural resources. By recycling glass, we reduce the need for raw materials like sand, soda ash, and limestone, helping to preserve these resources for future generations. Have you ever wondered how the microchips that power modern technology and artificial intelligence are made? No, they don't fall from the sky or grow like mushrooms in the forest. They are the result of incredibly complex processes that demand extreme precision and automation. Let's dive into the world where pure silicon becomes the brains of our devices and discover just how much effort goes into making it possible for you to ask an artificial intelligence, "How do I talk to a girl?" The primary material used to manufacture chips is pure silicon. The choice of this material is no coincidence. Silicon has semiconductor properties that allow it to efficiently conduct electric current under certain conditions, which is essential for creating microchips. But silicon crystals don't just appear out of thin air, they are grown. Like mushrooms, can you imagine? Specialized companies are responsible for growing silicon, providing the semiconductor materials needed to produce microchips. The main suppliers are Japanese, Taiwanese, German, and American companies. Silicon monocrystals are formed using the Czochralski method, where silicon is melted and then gradually cooled to form a large cylindrical ingot. In a high-temperature furnace, a seed crystal, also called a seed, is slowly pulled from the molten silicon while rotating. This ingot is then sliced into thin silicon wafers, usually between 200 and 300 microns thick. These silicon wafers are polished to a perfect smoothness and cleaned of any contaminants to prevent defects in the future microchips. This is done using special chemical solutions and mechanical procedures. Next, chip designers create the architecture, which includes millions of transistors, logic gates, and other components necessary to perform artificial intelligence tasks. This is an incredibly complex process, requiring a high level of specialization and the use of automated design software. First, they design the chip's architecture, the structure and layout of all the components. The architecture of an artificial intelligence chip may include graphics processing units, neural network processors, and specialized computing blocks designed for high-efficiency matrix operations. During the design verification phase, computer simulations are used to test and validate the design. This allows for the identification and correction of errors before moving on to physical production. The next stage in chip production is called photolithography. Photolithography is a crucial technology for manufacturing microchips, involving the creation of the pattern for future electrical circuits on a silicon wafer using light. This is one of the most critical steps because it determines the precision and density of the components on the chip. A specialized robotic machine, equipped with tweezers to avoid direct contact and prevent contamination, handles the silicon wafer. The machine then immerses the wafer in chemical baths with cleaning solutions to remove any dust particles, oils, or other impurities. Afterward, the wafer is placed on a machine that spins it at high speeds to evenly distribute a layer of light-sensitive material across its surface. It's similar to placing the wafer on a fast-spinning disc and dropping liquid on top, allowing the material to spread out through the spinning motion. To apply the pattern onto the wafer, a process called light exposure is used. A machine, similar to a large projector, uses a photomask, essentially a template that allows light to pass through in specific areas. This projector directs ultraviolet light through the photomask, and the light reaches the photoresist only in certain spots. It's like using a stencil for painting, where the paint only goes through the cutout areas. After exposure, the wafer is again immersed in a chemical solution, but this time to develop the image. The solution dissolves the parts of the photoresist that were exposed to the light, or the parts that were not, depending on the type of photoresist. Think of it as developing a photograph, where the details of the pattern emerge in the chemical bath. Once the image is developed, the wafer moves to another machine for the etching process. This is similar to carving and is called etching. The machine either sprays gas plasma onto the wafer, dry etching, or immerses it in a chemical solution, wet etching, to remove the unwanted material, leaving only the necessary parts behind. In the final stage, the wafer is cleaned again to remove any remaining photoresist. Machines immerse the wafer in chemical solutions or use special laser technologies to ensure it's thoroughly cleaned. Can you imagine how much micro-level work goes into all of this, just so my friends can ask artificial intelligence how to approach a girl? Or, get this, I overheard some girls asking ChatGPT to do tarot card readings for them. So, here we have people and machines working hard, meticulously developing technologies, and then someone's like, pull a card of the day for me. Admit it, do you get asked to do that kind of crazy stuff often? Anyway, let's continue. After the remaining photoresist is removed, the silicon wafer undergoes a visual inspection using microscopes, but it's all done by automated systems, robots and cameras scanning for even the tiniest defects to ensure everything is flawless. At every stage, nearly everything is handled by automated machines, because even the smallest mistake or speck of dust can damage the microchips. Humans mainly monitor the process, adjusting machine settings and troubleshooting if any issues arise. To create regions on the wafer with different electrical properties, a process called ion implantation is used. This involves introducing impurities into the silicon. Ions of a specific material are accelerated and embedded into the silicon wafer, altering its semiconductor characteristics. After implantation, the wafer undergoes a process called annealing, heating the wafer to activate the ions and restore the crystal structure of the silicon. Next, layers of metal, typically aluminum or copper, are applied to form electrical connections between the transistors and other components of the chip. After manufacturing is complete, each chip undergoes a thorough inspection for defects and a series of tests to confirm its performance. The testing includes checks for functionality, speed, heat resistance, and energy consumption. Chips that do not meet quality standards are either discarded or recycled. This process ensures that only products fully meeting all technical specifications are retained. Packaging chips is the final stage of production, where the finished chips are prepared for use in electronic devices. This process is also primarily carried out by automated machines. First, the silicon wafer, which contains hundreds or even thousands of chips, needs to be cut into individual chips. A special laser machine, or a precision diamond cutter, is used to slice the wafer into separate tiny chips. This process is called dicing. Once the wafer is cut, each chip is attached to a substrate, base, which helps connect it to the rest of the electronics. An automatic die attach machine picks up each chip and precisely places it on the substrate, using a special adhesive or other material to secure it in place. For the chip to interact with other components, it needs to be connected to the substrate with very thin wires. This is done using a wire bonding machine, which welds fine gold or aluminum wires that link the chip to the contacts on the substrate. After the chips are connected, they must be protected from mechanical damage, dust, moisture, and other harmful elements. To achieve this, the chips are enclosed in protective casings. An automatic chip packaging machine covers the chip with a special plastic or epoxy resin. This process involves encapsulating the chip in a protective material, creating a durable casing around it. After testing, the chips are marked with information such as the model, serial number, and other relevant data. This is done using laser marking machines, which quickly and accurately apply all necessary information to the surface of the chip's casing. Once testing and marking are complete, the chips are packed into anti-static boxes or specialized plastic tapes for easy transportation. Automated packing machines organize the chips in rows, package them in special containers, and prepare them for shipment to customers. The chips are inspected to ensure they meet all standards and are ready for transport. This process is overseen by logistics personnel and automated systems, which manage the warehouse, sort the products, and handle shipping to clients. Imagine a place where time seems to stand still. Deep underground, nestled in the mountains of Pakistan, lies one of the most remarkable mines in the world, the Quira Salt Mine. This place is more than just a mine. It is the largest producer of pink Himalayan salt, renowned for its purity and rich mineral content. The Kira mine is an expansive underground complex made up of numerous tunnels and chambers where salt extraction continues without interruption. From the very beginning of my journey, I felt as though I had entered another world. The entrance to the mine looks like a gateway to an ancient, almost magical realm. Here, they extract some of the purest salt on Earth, the famous pink Himalayan salt. Let's walk through the old tunnels together and discover how this remarkable process takes place. The walls of the mine are lined with layers of pink salt, and each layer tells its own story, preserving the memory of millions of years of geological activity. The sense of descending deep into the earth is heightened by the near silence, broken only by the echo of footsteps and the hum of machinery at work. Salt extraction at the Kira mine is carried out using traditional methods that have changed very little over the past 200 years. It all begins with drilling holes into the salt walls. Miners use powerful drilling machines to bore holes into the rock. Drilling is a crucial and delicate step, as the precise placement of the holes determines the efficiency of the entire process that follows. Once the holes are ready, the workers carefully insert gunpowder capsules into them and connect them with wires. This must be done with extreme precision to ensure that the blast does not compromise the structure of the mine or create safety hazards. For each borehole, they use 4 capsules. Once all the charges are set, the blast occurs, separating large chunks of salt from the wall. This process requires great accuracy and skill to avoid damaging the surrounding salt layers and to maintain safe working conditions. After the explosion, the cleanup phase begins, which is also a labor-intensive task. Workers use special equipment and manual labor to carefully sift through the debris, selecting the best pieces of salt. This phase can take several hours, and sometimes an entire day, depending on the volume of salt being extracted. After the explosion, workers use excavators to clear away the large chunks of salt. The excavators lift these blocks onto special carts, which then transport the salt to the sorting area. Here, the highest quality pieces are carefully selected by hand. This process is time-consuming and requires great attention to detail to ensure that only the best salt makes it to production. The miners break the salt into smaller pieces, which are then meticulously sorted for further processing. It is remarkable how crucial the human element is in this operation. Only experienced workers can determine which pieces of salt are suitable for refining. They assess the color, clarity, and texture of the salt to choose the best material. Working in the mine is not only physically demanding, but also dangerous. Humidity and temperature in the mine often fluctuate, and the salt can become slippery. Miners must remain vigilant at all times to avoid injury. Despite the challenges, they take great pride in their work, knowing that their efforts benefit millions of people around the world. Once the salt has been brought to the surface, the next phase of processing begins. First, the salt is sorted by size and color, with only the purest and most visually appealing pieces moving forward. Then, the salt goes through a washing stage. Large chunks are submerged in huge vats of water, where they are thoroughly washed to remove any impurities. This step is crucial to maintaining the product's high quality and ensuring its cleanliness. The washing process is repeated several times until only the purest salt crystals remain. Each cycle is carefully monitored to ensure that every grain meets strict quality standards. Washing is one of the most labor-intensive stages, as the salt must then go through the drying process. First, the salt is pressed to remove excess water, and then it is placed in special drying chambers where it slowly dries. This method helps preserve the salt's natural structure and unique properties. It's essential that the salt remains as natural as possible, and the washing process, free of chemical additives, guarantees this. One of the most fascinating stages of salt processing is the creation of Himalayan salt lamps. Craftsmen carefully shape large chunks of salt by hand, giving them a variety of forms. Each piece is given a unique shape. Some lamps retain a rough, natural look, while others are crafted into smooth spheres or pyramids. After shaping, the salt is washed again to remove any remaining impurities. Then, the craftsmen insert electrical components, transforming the salt block into a lamp that emits a soft, warm glow. The process of making salt lamps begins with selecting the right chunk of salt. Using specialized tools, artisans shape the piece, a process that can take several hours since each salt block is unique and requires an individualized approach. Once the shape is finalized, a hole is drilled into the salt to accommodate a light bulb, and the electrical components are installed. Every lamp undergoes a quality check to ensure it is safe and built to last. In addition to lamps, the factory also produces other salt items, such as bowls and pyramids. These pieces are handmade, making each one a unique work of art. The lamps come in various sizes, ranging from small to very large, with some weighing up to 20 or 30 pounds. These creations serve not only as beautiful interior decorations, but also as sources of comfort and warmth in the home. Each product is subject to strict quality control, and only those that meet high standards are made available for sale. After the salt goes through the stages of sorting and washing, it is ground into fine crystals. The salt is then sent to the purification stage, which involves several additional steps. The crystals are passed through large rotating drums, where they are heated to remove all moisture, making them dry and ready for use in the kitchen. This process is crucial for preserving the flavor and quality of the salt. Each step of the processing is carefully designed to ensure the final product is of the highest quality. After drying, the salt undergoes a grinding process. Special mills are used to crush the larger crystals into smaller ones. The salt is then sifted to separate any particles that are too large. These larger particles are sent back for further grinding to achieve a uniform consistency. This step is important to ensure the salt is convenient for kitchen use and has crystals of a consistent size. Once the grinding is complete, the salt is checked for impurities. It is passed through magnetic separators to remove any metal particles and through optical sensors to detect other contaminants. Only after the salt has passed all inspections is it sent for packaging. After all the processing stages, the salt is ready for packaging. First, it is packed into large bags for bulk distribution, and then it is portioned into jars or packets for consumers. Each packet retains the salt's beautiful pink hue, a sign of its natural origin and rich mineral content. Workers manually inspect each package to ensure everything is done correctly, and the product quality remains top-notch. It's a meticulous job, but this careful inspection ensures consumers receive a high-quality product. At the packaging stage, modern equipment is used to speed up the process and minimize direct contact with the salt, which is essential for maintaining its purity. The salt is packaged in various forms, from small plastic jars to large bags for restaurants and food industry businesses. After packaging, each batch of salt is labeled with the production date and expiration date, so consumers can trust the quality and freshness of the product. It's said that Himalayan salt lamps help purify the air and reduce radiation from electronic devices. While there is little scientific evidence to support these claims, many people find that the ambience created by these lamps does help them relax. As for Himalayan salt used in food, it contains about 84 minerals, including magnesium, potassium, and calcium. These minerals can help maintain balance in the body, improve digestion, and regulate fluid levels. Incorporating Himalayan salt into your diet may be a beneficial addition to a healthy lifestyle. Himalayan salt is also known for its therapeutic properties. Some people use it for salt baths, which help with relaxation and can improve skin condition. Additionally, it's used in salt inhalation therapy for respiratory issues. Its natural composition and lack of chemical additives make it a preferred choice for those focused on their health. Himalayan salt also has a milder, more complex flavor compared to regular table salt, making it popular among chefs and food enthusiasts.